which are the formulas we need to use here. This says the percentage of people in a population who have a certain disease is 11%. All right, so let's just write that down. Oops, let me get to a pen. Probability you have this disease is 11%. There is a test for the disease that is fairly accurate. Of the people who have the disease who take the test, it reports 3% of them do not have the disease. All right, now this can get really, really complicated, so don't give up on it. But what I just read there, of the people who have the disease, so given you have the disease, given that you have the disease, it reports, and you take the test, it reports that 3% of them don't have the disease. So that means you're testing negative for, even though you have the disease, you're testing negative for it 3% of the time. That's called a false negative, 0.03. So you have the disease, but you're still testing negative for it. Of the people who do not have the disease, okay? So I don't have the disease. So this is how I'm going to write that. I don't have the disease. It reports that 2% of them have the disease. So I'm testing positive even though I don't have the disease 2% of the time. Suppose that a person takes the test and it reports that they have the disease. So we got a person that at least gets the test back and says they have the disease. So they are testing positive. Compute the probability that the person does indeed have the disease. So here's what I'm looking for. I am, suppose that a person takes the test and reports that they have the disease. So I have tested positive. What's the probability I actually have the disease? That's what I'm looking for. Round your answer to 2 decimal places. Okay, so this is what I'm looking for. All right, and since it is the okay, so using Bayes' theorem, I'm looking for this right here, the probability that given they've tested positive, what's the probability they actually have the disease? And so if I use Bayes' theorem and write that out, these are the things that I'm going to need in order to figure it out. So I need to know, first of all, let's just see, what's the probability someone has the disease? Well, if I go back and look at my problem, that was 0.11. That's going to go down here too. And this is going to be 0.89 because probability they don't have the disease would be 0.89. The other thing I'm going to need right here is what's the probability, given they have the disease, what is the probability they tested positive? Well, if I look up here, I don't see that anywhere, but I do see if they have the disease, what's the probability they test negative? So since that's 0.03, the complement to that would be testing positive and have the disease and testing positive, which would be 0.97. So that's going to go here. That's going to go here. And then the last thing that I need to plug in is not having the disease. Given that you don't have the disease, what's the probability of testing positive? And that's 0.02. All right, so then it's just a matter of typing all that stuff in. Get about how many decimal places? 2 decimal places. 0.86. There's about an 86% chance of, given that you tested positive, that you actually have the disease. All right, you're going to need to practice. Bayes' theorem. I'm going to erase this and draw it a little bit nicer for you. So Bayes' theorem is the probability of B given A is equal to the probability of A given B times the probability of B, all divided by something that hopefully is going to look a little familiar to you, because on the bottom of this it's just the law of total probability. It's the same formula we just looked at. All right, let me get that erased here. All right, so again, I'm going to read through this problem. I'm going to write some stuff down and then try to plug it in. Okay, so here we got a factory with 2 machines, A and B. They manufacture washers. Neither machine is perfect. Machine A produces defective washers 20% of the time. Machine B produces defects 15% of the time. Machine B is more efficient than A and accounts for 65% of all the total output of washers. All right, so the probability of a washer coming from B is 0.65. So that means the probability of it coming from A is 0.35. For the purposes of quality control, a simple washer is taken and examined for defect. Compute the probability that a randomly chosen washer found to be defective was manufactured by A. All right, so here's what you got to be able to do. You got to be able to take this sentence and write a probability equation for it. So here's what it's going to look like. It says, compute the probability that a randomly chosen washer found to be defective. So given that it's defective, so given that you have a defective washer, what is the probability it came from machine A? This is what we're looking for. Okay? So this is, now I think of that as this right here, and then translate it and try to write this equation right here. So if I were to do that, and just, it would come out to be the probability of A given that it's defective. And if I plug it into this formula up here, it would be the probability of being defective given it's coming from A times the probability of A over exact same down here plus the probability of it being defective coming from the other machine, which is B, times the probability of B. Okay, so then it's just a matter of plugging stuff in. And if I go back and read up here, it says a machine produces defective washers 20% of the time. oh, that's A, machine A produces, so the probability, and put that in red over here, 20% of the time, if it's given that it's coming from A, it's defective 20% of the time, and given it's coming from B, it's defective, what's that, 15% of the time. So, I think I've got everything I need to plug into this formula right here. This is going to be defective A. This is going to be 20%. Probability of A is 0.35. This is 0.20. This is 0.35. This is 0.15. And this is 0.65. Oops. All right, so then once I got everything typed in, I type those numbers in my calculator, get my answer. 0.20 times 0.35. So that's equal to 0.07 over 0.1675, and that's going to give me did I do something wrong there? Let me check this again, because usually I get a nice number. Seven divided by 0.1675. Round your answers to two decimal places. I'm getting 0.42. I'm going to check that to make sure it's right. So if it's still on the video, it must be. But if not, I will have changed it. All right, let's see if we can read a problem and figure out which. All right, here's the last one, homework 4-10. And it's going to be over the law of total probabilities and Bayes' theorem. Okay, so law of total probabilities is written above right here. And you don't have to memorize this equation. This equation will be given to you. You just need to know how to use it and when to use it. To really understand this equation, it's important that you realize or understand how to read something like this, okay? And this is given B happens, what's the probability of A? So when you have something like this, the other thing you need to understand is, what does this mean? When you have that little bar over it, that means what's the probability that B is not going to happen? What's the probability of not happening, getting B? Okay, so if I were reading this whole law of total probabilities up here, probability of A is equal to the probability of A given that B happens times the probability of B plus the probability of A given B doesn't happen times the probability of B not happening. All right, so the way that I learned how to do these was reading the problem, writing everything I could down, and in terms of a probability statement, and then going from there. So let's read this together here. Archie's stranded in a war zone, foreign land. His only chance of survival is to reach Sudland, okay, which lies 100 miles away. This 100 has nothing to do with the problem. All right, don't let it distract you. There are just two routes to Sudlin. One is through the desert, the other is a long trek through the mountains. Both routes are terribly dangerous. In the past, 38% who tried to reach Sudlin failed. All right, so here's what I'm writing. They just gave me the probability of getting to Sudlin is, be careful here, the probability of getting to Sudlin is 62%. All right, so the first time, I'll be honest with you, the first time I did this, I missed it because I wrote the probability of getting to Sudlin was 38%, but it says 38% of all who tried to reach Sudlin failed. So the complement to that, to reach Sudlin, would be 62% because 38 and 62 add up to 100. All right, so there's a tricky part right off the bat. Next thing, it says, of all the attempts to reach Sudlin, 8 out of every 35 were by the desert. Okay, so I'm going to say the probability that I go by the desert or someone goes by the desert is, what was it? 8 out of 35. That means the probability of going by the mountains must be 27 out of 35. Okay? And then it says, although it is a longer route, the mountains seem to provide more success. I'll erase some of this, but it says 70% of those who attempt to reach Sudlin through the mountains are successful. Okay, so here we go. This is maybe the most difficult part for people. Mountains seem to provide more success. So given that you go through the mountains, the probability of reaching Sudlin is 70%. Now the question you have to answer is, of course, Archie is not going to go through the mountains. He's going to go through the desert. What's the probability he gets to Sudlin? Okay. So it says Archie intends to go through the desert. What's the probability of making it through the Sudlin? So given that he goes through the desert, what's the probability he gets here? This is what we don't know. This is what we're looking for. Okay. So the probability of getting to Sudlin is my total probability here. That's the probability of A. That's what's going to go. That's what's going to go right here. So I'm going to have 0.62. Let me write it out in words first. So the probability of getting to Sudlin is equal to the probability of getting to Sudlin through the mountains times the probability of the mountains plus the probability of getting to Sudlin through the desert times the probability of the desert. Okay, so my total probability of getting to Sudlin are these two things added together. And I can plug something in for all of these except one. So the probability of getting to Sudlin, boom, 0.62. Probability of getting to Sudlin through the mountains, so you go to 0.70. Put it there. Probability of going through the mountains, 27 over 35. Probability of getting Sudlin through the desert, that's what I'm looking for. And then the probability of going through the desert is 8 out of 35. All right, so now I just have an algebra equation here that I need to solve. So I type this in my calculator. And like I said before, I messed this problem up earlier, and I knew I'd made a mistake because at this point, I didn't have 0.62 here. I had the 0.38 that they gave me. And when I tried to solve it, I was getting a negative number, so I knew I'd done something wrong. So it took me a second to go back and figure that out. All right, and now I'm just going to multiply both sides of this equation by 35 divided by 8. And I get x equals 0.35. So there's a 35% chance of Archie making it. All right, that's the law of total probabilities. So again, you don't have to memorize this equation, but you will know how to use it. And I'm telling you, you're just going to have to practice. All right, let's head on over to